Okay, thank you very much for the time and welcome to the Kohei Arai Sensei in our collaborations. Okay, in this time, I will try to present uh, my research related to the deep learning applications on several topics. So, the first that I would like to talk about is the facial expressions. Recently, this is my first collaboration with the students since I come back to the Indonesia. So they are interested in the uh, deep learning topics, and I offer them facial expressions topics since it's very challenging. So the facial expressions datasets is getting larger in the number and then more complex in terms of the labels and the data itself. As you can see here, that sometimes what we call sadness, there are so many sadness profile in data sets. Different humans maybe has different expressions to show the sadness, surprise, nature, and so on. So we make use the abundance of data on the internet. So we would like to improve the deep neural network to get the higher accuracy for detection of facial expressions. So technically, we we are modifying the networks so it can maximize the accuracy. First, we use the some kinds of module called accuracy booster, which replace this intermediate layer of the uh, residual network to the convolution by multiple one. Okay, the size, yeah, this is the
Mhm.
dimensions, and then we also propose some kind called uh, network with mesh activations. So this mesh activations has the special property to boost the accuracy. So also, the another students try to propose the attention module to be attached on the network, and this attention will attend the specific uh, features inside the network. So it could attend more into the important features. So this is hopefully will improve also the quality of the detections. So based on the results, it shows that our proposed method gain the highest accuracy on the largest data set on a facial expression called AffectNet by 0.5 59. Recently, there are also more and higher accuracy, but that was the reason. Another research on that time we got the highest accuracy. Also, it shows that also the attention module improve the quality of the detections. You can see there are improvements after attention module is attached into the ResNet 15 backbone for the all data set, either training or testings. Okay, so in this time I will show you the can I show you the demo? Maybe actually it's a YouTube. I don't know whether it can be accessed or not. Okay, so I will continue. Okay,
Mhm.
for the efficient time. So now the second one.
Just second. May I ask the questions
Okay,
anytime?
anytime. Yes, please.
Okay. You must know the Face API
Oh yes,
and YOLO V3.
yes, yes, yes. I know.
Mhm.
Mm,
YOLO V3 allow us
mm.
to detect face
Oh yes,
clearly, almost
yes.
100%.
Okay.
And Face API
Yes.
allow us to recognize
Mm.
the emotion.
Oh, okay.
Mhm.
Okay.
So that the your method will be better to compare with the Face API.
Oh, Face API. Oh, okay.
Mhm.
Yes.
As far as I know, the recognition accuracy of the Face API is the champion.
Oh, okay. Face
Mhm.
API.
Yeah,
Yes. Okay. Okay. I
please
would like to
compare it.
explore. Yes.
All right, all right. Move on to the next topics.
Okay.
Mhm.
Thank you very much for your suggestions. We will try to explore the Face API.
Yeah.
Okay. And then, okay. Now we are trying to explore the efficient deep neural networks on first the large scale path recognition and the satellite image classification. Recently, our students do these research topics on their final project of
Mhm.
the final project bachelor.
Oh, I see.
Okay. Okay, the first the satellite image classifications. They are interested because there are so many applications using drones and so many embedded systems. However, the need of efficiency and is compulsory, so it can be embedded or it can be saved into their memory efficiently. And that reason, we are gonna uh, explore how to minimize the number of parameters inside the CNNs. However, also maximizing the accuracy of the detections. So we make use of the large scale satellite image datasets, and then the exploration shows that the efficient net got a very efficient in terms of the number of parameters compared to another backbone model. So it can be shown here, it gained the accuracy nicely with a minimum number of parameters. Also, if we can compare into the another model, efficient net shows the higher accuracy while the number of parameters stay minimum. So how to modeling the efficient nets? There are so many ways. So it can
Mhm.
be scaling in the width, scaling in the depth, and scaling in the resolution, or the component of the all the scalings. So
Mhm.
technically, they are on the papers. And then after that, we are trying to apply the pruning. So after the efficient model, we are properly trained. So we select which the weight that is more uh, uh, will give the contribution to the decision. So we are doing a pruning by prune. Uh, this is a structured weight pruning or unstructured weight prunings.
Mhm.
So it is found that we after we unstructuring the weight pruning, it got the overall accuracy stays not far from the uh, baselines. However, we can see that I'm sorry, this is not training time. It's a wrong typo. It should be number of parameters. We can show that number of parameters is cut by half. So it stays high of the accuracy, but we can cut the number of parameters by half, which is actually efficient in terms of memory.
Mhm.
Okay, so there are another problem from the satellite dataset is that the noisy label. So there are some data that is noisy that should be addressed to maybe improve the accuracy. So the idea is we are using the label smoothing. So on the in the preliminary result, it can show that the distribution is more into the more better,
Concentrated.
yes, yeah, concentrate, yeah,
Mhm.
rather than the diverse from the befores. So maybe this is the way how to improve the accuracy, given the problem. Yeah.
Good.
So maybe we can we can wait for the students for their experiments. And then the second one,
Mm.
large scale face recognitions, we make use of the more than 70,000 data and 102 classes.
Mhm.
So the problems stays the same. The need of efficiency and so that applicable to be embedded to embedded sense systems or mobiles by minimizing the number of parameters while also maximizing the accuracy. So this is challenging data set actually because actually the past occurs in many scales. There are many occlusions. Sometimes they are hiding behind the leaves. It's difficult for algorithm to detect. So we propose several methods to improve small CNN models to do that purpose. First, we are employing data augmentation via CutMix. Second, we exploit sparse regularizers, and we train it with the dynamic learning rate. And also, we do the training strategy by first freezing the convolution layers after several epochs. Then
Mhm.
we are fine tuning the all layers. It shows by the graph that it's improved. So this paper is still uh, in the
Mhm. Yeah.
revision major in the good journal. So hopefully, if we can revise it well, maybe it can publish. Maybe, hopefully,
Mhm.
maybe your you, your support also.
Mhm.
And then generally we found that a mobile networks two got the lowest and the total number of parameters uh, while also keeping the accuracy still reasonable. And then we use those combination previously it uh, uh, boosting the accuracy of the plain mobile networks 2 by, you can see there is a 0.71 percentage. Yes. 0.71 percentage. Even this accuracy beating the more higher number of parameters model like ResNet and so on. So we have searched the recent papers also. So this accuracy is concluded as the highest one.
Mhm. Mhm.
Okay.
Good.
Okay. And then the next topic is still ongoing research related to your topics or the
Yeah.
safety
Yeah. Yeah.
workers. Yeah.
Mhm.
Okay. There is the one students that doing this, and but still not finished yet. But the idea is the transfer learning from the large virtual worlds data sets, given uh, the difficulty and the
Mhm.
security uh, problems for gathering data from real worlds. So from transfer learning and fine tuning, hopefully maybe how much the improvements, how much the accuracy we can get, uh, we will know after the experiments. This is a preliminary. This is our ideas. Yes, to yeah, improve the capability of the safety worker. In this case, appliance detections. And then also I will talk about the transformer network. Recently, in the deep learning improves, yeah, and they found several drawbacks on the convolutional neural networks. So recently there are the new backbone or the architecture called transformer network, which beating CNNs all the way. So we will try this on the application of the mask face recognitions. This is quite challenging because the mask, the way people wear the mask is so various. So here, sometimes they wear the mask properly, sometimes it's incorrectly, and so on. We have 4 types of classes which show how the people wear the mask, which the data more than 100,000 data. So uh, the uh, the power of the transformers that it make use of the self-supervised learning from large ImageNet dataset, as by masking of the randomly arbitrary patches of the image, and a network should guess what's the patches that must being masked, like that on the large dataset. So we only fine tune on the task specific, such as mass detection. And they also they're employing the attention mechanism inside the transformer encoder, so it also have a contribution to improve the detection quality. So here's the results. So we are far better than the ResNet. ResNet is the popular CNN-based network in all train validation and tests. There are 3 types of the fission transformers, depending on the how many layers they are inside. Also, when we use the GradCam to see the intermediate layer attention, it shows that the transformer network attend properly than the CNN-based ResNet. You can see that sometimes which one is the mask, so the transformer is clearly they attend to the goals, the center of the attention, other than the CNN-based ResNets. That's the interesting. Also, this is also a demo. Maybe it's difficult. Okay, and then also we did the image colorizations based on the UNet and fusion layers. Previously, we have used the UNet in many applications, such as the segmentation of the cells, and then also we have ever done on the some medical images. So now we are trying to incorporate UNet and fusion layers to improve the image colorizations. So we put this paper on archive for these papers, and then this is the architecture of the UNet, which is basically based on the ResNet encoder here, and also we adding the fusion layer here. So what's the effect of the fusion layer? And UNet, actually we are incorporate the pre-trained encoder here. So the pre-trained can boost the quality of the polarizations, and also the skip connection here, which is the special characteristic of the UNet here, also I think have the contribution to the results. Like this, in the in the in the below here is the previous colorization method from Zhang. This is from a dataset, a real dataset taken from the YouTube. So we are framing the each frame of the, we are extract the images from the videos, and then we can see that our get a more colorful and a more better results compared to the previous. The the failure is that the human, when we colorize the human, the color is not good. So there's some sepia and another color which is far from the definition of the humans. So maybe we can improve this on the next. And this is also demos, but it's okay if it cannot be run here.
That's
Okay.
okay.
Okay, and then the another one also the action recognitions. Recently in my PhD, I was doing the action recognition. Here in my student do the violence detection of the CCTV camera video using a spatio-temporal deep learning. As you can see here is the high degree of freedom on the violence occur inside the videos. So we try to propose the two stream to the CNN also, and then also we'll try to improve it into the 3D CNN. So how is the results? So the preliminary result using the pre-trained large kinetics datasets on the well-known RWF violence datasets, we got the best accuracy about the 0.88 of the accuracy. So its training is still ongoing. So maybe we can achieve another results. And then this is another line of the research. Is not the image, not the videos, but is the time series dataset. We also predicting the time series, especially in the case such as COVID-19, and we incorporate the deep learning algorithm like LSTM, long short-term memory, transformers, also to predict the time series. So we do it by incorporating the multivariable, so not just one variable. We can show that the multivariate LSTM has a better error than univariate on the each variable for this lower error, lower prediction error. Okay, so that this very advantageous if we incorporate multivariate analysis on the time series predictions. And then this maybe this is last. This is AI explainable. Recently, like that, previously you saw from the transformers on the masking, they are also highlighting the attention of the network. Also, we try to do the same thing on the time series data, and it's interesting. So we a network can attend to the most variable and the and in the time in which time they are very influence to the predictions.
Mhm.
So they are highlighting several variable and time frame which contributing into the predictions. So it requires large data sets. As this is interesting that data-driven AI explainable can shows the factors that contributing into the prediction. So we can do a lot uh, more research like this. Okay, this is the several research uh, from us, Arai Sensei.
Mhm.
Thank you for your attentions. Thank you very much.
Okay,
A
thank you
couple
very
of
much. Maybe next Professor Kohei Arai have some comments.
yeah, a couple of the questions, not the comment.
Okay, Professor.
Yeah, first one is the VGG 16.
Yes,
You tried VGG 16, but
yes.
as far as I know, VGG 19 is show the better performance
Oh, okay.
rather than the
Yes.
VGG 16.
Oh, okay.
So you would better to compare
Yes.
your method with the not the VGG 16, VGG 19.
Oh,
I
yes. Okay.
recommend.
Yes. Thank you very much.
And wearing a mask, there are four types of the mis yeah, wearing method.
Yes.
Yep. And you made a classification, the
Yes.
four categories.
Yes.
And transformer network show the better performance.
Yes.
It is a summary of your research work.
Yes.
EIT large 16. The number of the layer is the 16. Am I right?
Yes. Yes.
Hmm. Do you know why?
Maybe this the
Hmm.
attention are also the pre-training. So
Hmm.
the transformer did the self-supervised learning before
Yeah.
training. Yeah.
Hmm.
So from the large data set, so they are capturing the patterns of the
Hmm.
large and various ImageNet data sets. Also with the attention mechanism, they can attend properly, like the example here.
Yeah.
Yeah. Maybe there are the several answers. Maybe we can. Also, this is the
Mhm.
CNN still too rough. They are
Right.
not
Right.
yes, not attention to
That's
attend to the
obvious.
specific.
That's clear.
Yes.
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 And most important performance is the test performance, not the
Test
validation.
performance. Okay.
Yeah.
Maybe there is the
You,
forfeiting.
you must know the holdout
Okay. Okay.
and K division cross validation.
Oh. Okay.
You know,
Yes. I know.
the number of K is a key issues for the evaluation.
Oh, yes.
Five
Okay.
division or three division, quite different performance will be evaluated so that the in this table you set validation performance and
Yes.
test performance.
Yes.
What is
Yeah.
the difference between both?
Okay. The validation actually so is supposedly used for the hyperparameter tuning, the validation one,
Mhm.
and testing is just test, so it's not contained inside the training process. So validation also is not trained. The validation is not trained. That just they
Ah,
show how what's the best hyperparameters
Mhm.
to
You
be checked.
used the training data set and test data set. Am I right?
Yes.
The percentage ratio would be 7 to 3 or
Yeah.
6 to 4.
Yes.
Uh-huh. And I recommend you to conduct the 5 division cross validation.
Oh, okay.
Yeah. In the table, the VIT huge 614 showed
Yes.
a good performance in terms of the test performance
Oh, yes.
rather than the VIT large 16.
Yes.
That's why it's very confusional
Okay.
result
Yes.
of the test performance.
Okay.
So I recommend you to conduct the
Okay.
5 division cross validation.
Okay. I agree with that.
And move on to the next slide.
Next slide.
Yeah, temporal, spatio-temporal.
Okay. This one.
Yeah. Mhm. So video action recognition, in particular, violence action detection
Yes.
using the spatio-temporal imagery data.
Yes.
So you used the LSTM for the prediction.
No, it's 3D CNN for the
3D CNN and
yes.
time
3D
series
CNN.
data.
Yes, yes.
Uh-huh.
Through over time. Yeah.
2 streams.
2 streams, yes.
Uh-huh.
Yes.
Oh, yes, yes. So one is a temporal. The
One is
other one
temporal.
is spatial.
Yes.
So 3-dimensional and 1-dimension. Am I right?
Actually, both are 3-dimensional. Just as this is just illustration. One is the optical flows, optical flows.
Oh, I see.
One is RGB. That
Makes sense.
both, yes.
Makes sense. Okay. And the other thing is time series analysis with the LSTM and
Okay.
transformer.
Yes. This one.
Okay. Yes. You know the LSTM is essentially linear prediction method.
Okay. Yes.
Mhm. But the COVID-19 showed the nonlinear trend.
Nonlinear trend. Yes.
Mhm.
Yes.
So event effect, not only the trend effect, event effect and seasonal effect you have to care about.
Okay. Yes.
In that case, I recommend you to use the Prophet, not the
Prophet.
LSTM.
Okay.
Prophet is provided by the Facebook.
Okay.
And Prophet has the long-term trend term and the term of the event,
Okay.
as well as the seasonal change term.
Oh.
That's why we can take the nonlinearity into account.
Oh.
Yeah.
How about the adding the activation function here after the layer of the LSTM?
Yes. This is important.
Okay.
So LSTM doesn't show that any nonlinear changes.
Yes.
But you add this, another layer.
Yeah. Yes.
That's why some of the nonlinearity you can represent,
Yeah.
but not the whole.
Yeah. Not whole.
So that I recommend you to use the Prophet rather than the LSTM.
Oh, okay.
Mhm. And accountability.
Accountability.
Yeah, grad can.
Oh, great count. Yeah.
Yes.
Yeah.
Right. Yeah, explainable. Explainable.
Yes.
You know, the one of the problems of the neural network
Yes.
is that it doesn't
Explainability.
have the accountability.
Yeah.
It's a black box.
Yeah.
So we don't know the logic in the neural network. But your grad can, we can explain the whole content. These are explainable. It's very important
Yeah. Actually,
for our research society.
yes.
And
Agree.
last week, I presented, oh, no. I didn't. Yeah, I'm working on the explainable deep neural network, which consists of the two stages of neural network.
Oh, okay.
Physical process can be represented as the two stages neural network.
Oh, okay.
It's good for the explain the logic in the artificial intelligence for in particular for the time series analysis.
Yeah.
Mhm. So if I have the another chance to talk with you, I
Yeah.
would show you
Okay. Okay.
my current research work.
It's pleasure. It's pleasure. It's a very interesting and promising research direction.
Okay, yeah. That's all.
Okay.
Okay, thank you, Professor Kohei Arai and Mr. Novanto Yudhistira for the presentation. So probably in the next sessions, Professor Kohei Arai would like to show some presentations regarding the current research in the Professor Arai fields. Maybe time is yours, Professor Kohei Arai.
Can you see my slide? Slide
Yes.
number one?
Yes.
Okay. I would like to propose the research work between the UA University that is called Work Safety at the Construction Site.
Okay.
One of the construction company in Japan required the some research cooperative research work, in particular for the ladder step ladder accident. The number of the step ladder accident in Japan for 5 years, 162. The most of case, the around this 50%, about half, human damage was serious. Some of the worker was dead by the dangerous action on the step ladder. Now this is an example. I intend to show the area. Red square show the dangerous area. If the worker on the step ladder get into the red colored square, then the worker will have the alarm warning from the speaker. Here's also, don't ride on the step ladder. So a worker step get on the step ladder, then the some alarm or warning or worker can hear. That is the final goal of our research work. Firstly, we have to watch the crosses, helmet, and shoes, and then they bring their step ladder at the required position and work on the step ladder. This is the regulation. Japanese regulation, safety regulation says durable structure, step ladder have to be durable structure. The materials is not significantly damaged, and the angle between the tripod and the horizontal plane should be 75 degrees or less. The tree has the area required for safe work. This is the regulation. But some of the worker don't care about these regulation. Forget about this. Yeah, another slide. This one here is the position of the step ladder placed. Pre-work, firstly, we would better to check the cross, safety shoes, helmet, chin strap, safety belt. Sometimes safety belt is dangerous. Craft with the step ladder makes a dangerous situation. 360-degree camera, watch the worker. And then step ladder by AR, augmented reality, display the precautions and leading dangerous movement from the GoPro. GoPro camera is the wearable camera mounted on the helmet. Acquire the image of the object the worker is looking at. And posture detection from moving image, we can use the open pose, allow us to extract the skeletonium, detection of the process leading to dangerous movement, then warning. I think the digital twin is useful for the reducing the step ladder damages. In this case, digital twin means the real world and virtual world. And the virtual world is very resemble to the real world, then we can simulate the worker's action in the virtual world. The worker can simulate. If the character in the virtual world make the dangerous action, but no one can damage it because it's in the virtual world. That's why. And then in the real world, the worker knows how the dangerous actions are through the simulation within the virtual world. Accident case video collection can be made by scraping, and deep learning can learn the dangerous action and time series analysis just before the dangerous action, the warning coming up. The digital twin construction with the metaverse and simulation. That is the scenario for mitigate the dangerous action. The location, now the step ladder usage, the surrounding area, we have to know. And these three photos show the dangerous action, not get on the step ladder or some others. This is not true. This is called standing horse, tachiyuma in Japan. By using the 360-degree camera, we could extract skeletonium. Then skeletonium had the temporal data so that the time series analysis can be done. We can predict the next action. If the next action is dangerous, then warning. This is the example of the skeletonium. Another example of the skeletonium. It's easy. And this one here shows the dangerous action with the stuntman right on the step ladder and falling down. This is one of the cases. Next one, step ladder had the unstable. That's why worker falling down. Another one, the worker works with the upper right, ceiling light. Fourth one, he intends to open the door and falling down. Fifth one, it's far from his step ladder. That's why he fell down. Some others. There are so many data. That's why we can learn with the deep neural network and the GoPro image, we can control the worker's action from the far areas, remotely control the worker's action by using the wearable camera imagery data. This one here is a Vuforia. Vuforia is the name of the software tools for augmented reality. It's easy to download it from the Unity side. Unity package, one of the Unity package is a Vuforia. And then install can be done. So that we can collect the dangerous action with the step ladder. And the image candidate displayed on the augmented reality. How to use in the ladder state. Don't get on the top of the plate. Don't straddle the step ladder. Don't sit on the top of the plate. Don't lean out from the step ladder. Don't work upward. Don't use the back of the ladder. Don't use when the opening step stopper is not stopped. These are precaution of the augmented reality image. This is an example of the 360-degree camera, 4K resolution. Wearable camera, here it is, 4K camera. By using these cameras, we can monitor the image the worker is now looking at. This is one of the research topics. The candidate with the collaborative work with you. Move on to the next one. That is the remote sensing satellite data analysis. This one here, this slide shows how to create the optical sensor data from the synthetic aperture radar data. Synthetic aperture radar data is electric magnetic wave imagery imager and the optical sensor image totally different. When the water flooding is occurred, the rain, heavy rain fall in such a weather condition and nighttime, suddenly, such a disaster will be occurred. So that the optical sensor data cannot be acquired. But the synthetic aperture radar penetrate the cloud, penetrate the rainy cloud. That's why we can get the synthetic aperture radar data in the night, in the weather conditions, rainy conditions. That's why I intend to create optical sensor data from the SAR data. Firstly, image translation, scene classification, and image restoration. We have to get the image restoration, fine resolution of the image data we would like to create, and the optical sensor data as a reference and the output of the image restoration compared together and feedback so that we can get the final resolution of the optical sensor data from the SAR data. That is my research purpose. Here I have the SAR, encoder and translator, and decoding, and generate the image. Discrimination, that means the high spatial resolution of the discriminator, and the optical sensor data. It's a real optical sensor data. For the learning process, we need the synthetic aperture radar and optical sensor data, downsampling, low resolution, and discrimination. And through the comparison between both, we could get the loss function. This is a GAN training process can be done with the GAN. Here I have the discriminator, fine resolution, and different resolution, and generator, and classifier. So a fine resolution of the resolution, the level can be compared to the low resolution of the classified result. For those who are not familiar with GAN, it's ENNET. You must know the ENNET is an encoder-decoder with a skipping connection between the encoder and the mirrored layer of the decoder stack. Here I have the idea of the GAN. X is the original image, and generator G reduce the image, but not equal to the input image. So we can learning the identifier D, and then X and Y is a real image. We can get the real result. This is the basic principle of the GAN. That's why we can get the optical sensor data from the SAR image data with the GAN. This is an example. 5 examples are shown in here. SAR imagery data, optical sensor data. This is the reference data, actual optical sensor data, and classified results are here. And you can look at this. Is a very close to the real classified result. Same thing for this, so that the last layer, fully connected layer, shows the good performance of the classified result. And this one here is the image restoration. Here, image restoration model. In the image restoration model, there are 3x3 convolutional neural network 128. This is your blocks. In the block, there are 3 by 3 convolution, ReLU activation, 3 by 3 convolution, and add the original. And this one here is plenty of layers, contains the 16 layers, and then finally 3 by 3 convolution. That's why we can improve the quality of the image that is called restoration. And here I have the example of the restoration result. Horizontal axis shows the number of the steps. SSTM, these are the method. And at last, at the step, number of the step is 20,000, almost fine resolution of the image were obtained. And this stored George. George is the name of the scene. Recovery obtained by different models, 500, 2,000, 10,000, 20,000 iterations, number of steps. The image quality is getting better and better. This one shows the example of the generation of optical sensor data from the SAR imagery data. Here I have the SAR imagery data. Right-hand side, you can see the optical sensor data. For candidates of the method which allow us to generate optical sensor data from the SAR imagery data. One of those is a pixel to pixel cycle GAN, pixel to pixel high definition, and FG GAN, image conversion. You can easily understand the FG GAN, pixel to pixel HD, show the good similarity with the optical sensor data. So we are now creating the FG GAN in our computer. This is the data translation. This one here, image translation model. In the model, cycle GAN, pixel to pixel, pixel to pixel HD, FG GAN are attempted. And then we could easily understand the FG GAN, pixel to pixel HD are most possible solutions for translation from the SAR to optical sensor data. This one here is a training performance and test performance. It's a loss function getting done, but no SAR data. And this one here, test performance. This one here is a training performance. Pixel to pixel, yes, FG GAN show the almost the same performance. This is a loss function, and the accuracy function is here. Same thing. The FG GAN and the pixel to pixel HD shows the good performance, almost 90%. And pixel to pixel image translation allows us to create the black and conversion from the black and white image data to a colored image. This one here is edge to photo. If we input edge image, then the pixel to pixel create the colored image. Input, output, input, output, input, output, and image input, output. You must know that. This is a big EarthNet Sentinel-2 imagery data set. Big EarthNet is the new large scale of the Sentinel-2. Sentinel-2 is the name of the satellite the European Space Agency created and is still working. It's a large database. That's why we can create the learning process using the Sentinel-2 and Sentinel-1. Sentinel-1 includes the SAR imagery data, and Sentinel-2 includes the optical sensor data. This one shows the how to improve the spatial resolution, so-called super resolution. By using CNN, we can improve the spatial resolution. Very deep super resolution, so-called VDSR. This slide shows the basic idea of the VDSR. Here, the high resolution of the image data, very sharp. This one here is a super resolved image from the low resolution image. Between both, it's easy to identify the difference between both. Spatial resolution are the difference. By using the elimination channel of the data, residual image patch can be created and reduce the residual image patch. We can get the fine resolution of the colored image. The Waifu 2X Cafe is a famous tool for the super resolution. We can create the high spatial resolution of imagery data from the low resolution of the image. The Waifu 2X allows us to create the color image from the black and white image, such and such. There are plenty of the software code. GitHub has such information, so we could attempt, we could try them, and the most appropriate software code we